Hello students, let us continue our discussion of the chapter Indefinite Integration. In the earlier modules we have seen the theories regarding integration by substitution. After seeing the theories, after seeing the corollaries, now let us take some examples, some problems based on substitution. Let us see the first example here students. The question says evaluate or find the integral of sine log x by x dx. Now this is what we are supposed to find. This is what we are supposed to evaluate. As always, we will first copy the question in the solution part and write it as I is equal to. So I am assuming the value of the integral as I. Now students, before we proceed into this type in detail, let us get some points very clearly. The very first thing you need to understand is that sine of log x is a composite function. Now what is a composite function? I believe you know very thoroughly from derivatives. Sine of log x is composite, and students, you may write one statement for your further use, further reference, that composite functions cannot be integrated directly. What am I saying? Composite functions cannot be integrated directly. Then how are we supposed to integrate composite functions? For integration of composite functions, either we need to apply some formula or we need to use method of substitution. What is that? The basic problem is you have integral of standard functions, a list of formulas which we have seen already. Only those are acceptable. Now here I have integral of sine log x. I need to remove that log x. So students, you may observe there is log x which makes that sine function as a composite one, but along with log x you see a x in the denominator, or you may say that you have 1 by x. Now if you recall from derivatives, log x and 1 by x are function and derivative pair. Log x is the function, 1 by x is its derivative. So students, what we can do in this case is, if they appear together in a integral, what we can do is we can substitute log x as t. Remember this student, when log x and 1 by x are together, we may substitute log x as t. So the very first step here I will write is let log x is equal to t. Obviously now we have understood in the theorem of integration by substitution that the next step is differentiate to convert dx to dt. So let us differentiate with respect to x. So what is derivative of log x students? It's 1 by x is equal to derivative of t is dt by dx, but I write the dx on the left hand side. So 1 by x dx will be replaced by dt and log x will be replaced by t to get the integral as integral of sine t dt. So what I have is now a very simple function, integral of sine t with respect to t, therefore the dt. Now students, what is integral sine t? We know that as a standard formula, integral of sine x dx is minus cos x plus c. So here in this case we will write minus cos t plus c. Now students, the question was in terms of x. So the answer also has to be in terms of x, and for that reason what am I supposed to do? We are supposed to resubstitute the value of t, and therefore the answer will be integral is equal to minus of cos of log x plus c. Is that okay? So whenever log x and 1 by x are together in an integral, we can substitute. Is that okay? Now having solved this sum, there are some more similar sums which can be solved using the same substitution, similar steps. What are those sums? There is a list for you. So all these sums can be solved by using the substitution log x as t and 1 by x dx as dt. Let us take one more example student. Here we have to evaluate the integral e raised to sine x into cos x dx. Okay, so what is the first step? Yes, we have to copy the question. So here we copy the question and we assume it to be some integral I. Now students, again if you observe, e raised to sine x is a composite function. So can I say e raised to sine x is composite? Exactly. Now students, what do we know from derivative? Derivative of sine x is cos x. So here we are observing that sine x and cos x are function and derivative pair. So if they appear together, what can we do? We can use the method of substitution to convert into a standard function. So therefore the first step will be let sine x is equal to t. Now students, if I differentiate both sides with respect to x, what do we get? we will get cos x is equal to dt by dx. So can I say that derivative of sin x is cos x and derivative of t with respect to x is dt by dx. Now I will transfer the dx to the left hand side to get cos x dx is equal to dt. Is that okay, students? What changes will occur in the integral? We will get integral of e raised to t, and with that it will be only a dt. That's a very simple function. Integral of e raised to t dt. Anybody's guess, integral e raised to x is e raised to x plus c. So here we can write it is equal to e raised to t plus c. Now again students, the answer has to be in terms of x. So we will resubstitute t, which is nothing but sin x. So here we can write the answer as e raised to sin x plus c, and that's how we evaluate this integral. Again, do we have some sums which are based on the same funda in the exponential form? Very much. And this is the list of sums where the exponent makes it a composite function. That's all we have in this module. Thank you very much.